Okay, let's look at the homework 3.7, number 6. Alright, so let's look for x-intercept of this function. It's a piecewise defined function. So we're going to set y equal to 0. Alright, so let's look at the top formula. So you have x squared plus 5, right? Then you realize that x squared is always non-negative, and you're adding 5 to it. So this quantity is always positive. So we can, this is never equal to 0, right? So we cannot get the x-intercept from here. But the second formula is 5 minus x. So if you set that equal to 0, you see that by adding x to both sides, we get 5 is equal to x, right? So therefore, there's an x-intercept, which is 5, comma 0, right? So from here, which is the right answer, right? To find the y-intercept, all you have to do is plug in y equals 0. So just evaluate y of 0, right? When x equal to 0, 0 is included on this interval, so which means that we have to use the bottom formula. So you have 5 minus x, but x is in this case 0, so is equal to 5. So y-intercept is 5, which means that the x is 0, then y is 5, right? So we got that. All right, so now we want to find the local maximum and the local minimum, or relative maximum and a relative minimum. All right, so let's take a look at the derivative. All right, so y prime is equal to, all right, so if you take the derivative of the top formula, which is x squared plus 5, which is just 2x, right? Then the bottom one, if you take the derivative of that, it's negative 1, right? So a derivative is 2x if x is less than 0, right? Right, and derivative is negative 1 when x is, right, greater than 0, right? Notice that I'm not including 0, because the derivative is actually isn't defined at that point. If you look at the top formula, if you plug in 0 for x, you get 0 for the derivative, and if you plug in 0, you get negative 1. So since these numbers are giving different numbers, which means that the derivative at exactly equal to 0 isn't defined. So I'll make a note of that. So y prime of 0 is undefined, right? But which makes x equals 0 is a critical number. So a critical number is x equals 0. All right. All right, so let's observe the signs of first derivative, y prime. All right, so critical number is 0, so I'll mark that. All right, so I'll just separate it using the dotted line, so y prime. All right, so let's look at the derivative when x is less than 0. So we can try like negative 1. Right, so if x is negative 1, it definitely belongs to the top one. So put negative 1 here, so it's negative 2. So the derivative is negative there. All right. If x is positive, like positive 1, then it belongs here. Derivative is actually negative 1, which means that the derivative is still negative. Right, we have that. All right. Therefore, since it's decreasing, turned into still decreasing, there is no local maximum or local minimum at x equals 0. Right? So therefore, relative max, relative min does not exist. right? So does not exist. Right? So we got those right? Then point of inflection. So let's look at the second derivative. So y double prime, right, is equal to, right? So derivative of 2x is just 2. So if x is negative, less than 0, derivative of negative 1 is 0 when x is greater than 0. All right? So sign-wise, it's easy to tell. If x is less than 0, it's positive because it's 2, right? But on the positive side, second derivative is always 0. It's not positive, it's not negative, it's always 0, right? So you have that, right? Which means that you're going to have you have a straight line there, and you can see that this is a straight line. All right. So you can see that the concavity change doesn't occur. So therefore, we know that there's no inflection point. So does not exist, right? So it's not very interesting there, right? All right, and as for horizontal asymptote and a vertical asymptote, you can see that vertical asymptote will not happen because this function does not blow up or shoot down to negative infinity anywhere. So therefore, vertical asymptote does not exist. All right. Then also, if you look at the limit of this function, f of x, actually, sorry, maybe I should call it y, as x approaches positive infinity, right? So we're talking about positive x value. We have to use the top formula, actually the bottom formula, sorry. So you have a limit as x approaches positive infinity of the bottom formula is 5 minus x, right? But the x goes to positive infinity, which means that the 5 minus infinity is negative infinity, right? We could not get a horizontal asymptote there, right? And we do the same thing. What about x approaches negative infinity, right? So since the x values are negative in this case, we're going to have to use the top formula. So we have x squared plus 5, right? But this guy, as x approaches negative infinity squared is positive infinity plus 5 is still positive infinity, right? So therefore, we cannot get a finite value. So therefore, there is no horizontal asymptote. Does not exist, right? So there are a whole bunch of does not exist, but this is it. I hope that this was clear.